Hi first years, this is your third lesson on decimals and today we're going to focus on inequality signs and also on reading from scales. So let's just remind ourselves what these inequality signs all mean again. The first one is quite self-explanatory. 5 equals 5. Whereas the second one, 4, does not equal 5. Now, the greater than and the less than symbols are the ones that you need to be really careful about when you're writing these. So 5 is obviously a larger number than 4. So we can say that 5 is greater than 4. And then the other way around, if we read this backwards, 4 is less than 5. Now, if a certain value is greater than or equal to itself, then later on in high school you'll learn more about this, but we could write things like this. An unknown value x is greater than or equal to 2. So that could be 2, 3, 4, 5, onwards. Then oppositely, an unknown value could be less than or equal to 5. So it could possibly be 5, 4, 3, 2, 1, 0, -1, and so on. Okay? Now, let's use a number line to help us decide on which inequality sign will be placed into these boxes. Now, using a number line, we know that on the left-hand side of 0, we have negative numbers, and on the right-hand side of 0, we have positive numbers. So we have here in our question -5. Now let's place a little arrow where -5 is, right here. And then -5.5. Now I might not get this absolutely spot on, but it's here. -5.5. Now which one is closer to 0? -5 is, meaning that is the larger number. -5.5 is actually a smaller number because it's more negative than this one is. So -5 is greater than -5.5. Okay, but the next example, 4.5 is a positive number. -2.5 is a negative number, so we should know straight away that a positive number is greater than a negative number. But let's just prove that on the number line. So positive 4.5 is here, and -2.5 is here. Now we've got a nicer gap here to look at. We know that this one, 4.5, is greater than -2.5. So we can place a greater than symbol in the box. Okay. Now without number lines, we might need to use our place value knowledge to help us out here. So we have 75.3 and 7.53 to look at. Now in terms of place value, 7 is in the tens column, 5 is in the units, and 3 is in the tenths column. And on this side, the 7 is in the units column, the 5 is in the tenths column, and the 3 is in the hundredths column. Now we know that if this number is starting in the tens column, that's definitely larger, so greater than. 75.3 is greater than 7.53. Moving on to 80.5 and 805. So if this is 800, so 800s, 0 tens and 5 units. And then we have here 80.5, so we've got 8 tens, 0 units and 5 tenths. Then the 805 is the larger number, so we can say that 80.5 is less than 805. Okay, now negative 0.04 and positive 0.03 next. Now, some people might look at the numbers only and think, well, 4 is greater than 3. However, this is negative 0.04. So that is smaller, is less than 0.03. So please be careful and look at the negatives and positives as well when you're reading the questions. Just take your time. For the next one, we have negative 0.250 and negative 0.205. So they're both negative numbers and they look quite similar. So let's just double check. We have 0 in the units column here. We have 2 in the tenths, 5 in the hundreds, and 0 in the thousandths. And then same over here. We have our tenths, hundreds, and thousandths here. However, this one with the 250 after the decimal point is actually a lot more negative than this one with the 205 after the decimal point. So even though 250 is greater than 205, negative 0.250 is actually less than negative 0.205 because it is a larger negative number. So it's going to be more towards the left-hand side of your number line of 0. So this one is more negative. Okay, let's move on to reading from scales. And let's figure out what the value is for A, B, C, D, E, F, and G using the gaps in between and also the numbers given. That's going to help us. Now, looking at G first of all, and the 9.9 and 10, we know that from 9.9 to 10, there is a jump of 0.1 because all you'd have to do is add 1/10 onto 9/10 to make one whole and get from 9 to 10. So we know that that gap is 0.1. 0.1 is the same as saying 1/10, okay? And there are 1, 2, 3, 4, 5 gaps here. So 1/10, so 10 divided by 5 is 2. So what we can say here is that this small gap is 2/100ths, because if the big gap here is 0.1, 1/10, then the smaller gap would be 2/100ths. Okay? Now, if we're trying to work out G, we know that one space along would get us to 9.92. Another space would get us to 9.94. Okay? 9.96, 9.98, and then 10. Now let's go back to the beginning, the first letter. Let's look at A. Now A seems to be right in the middle of 9.7 and 9.9. Let's just double check that. 1, 2, 3, 4, 5 gaps there in the scale, and 1, 2, 3, 4, 5 again. Yes. So what number is in between 9.7 and 9.9? Yes, you're right. 9.8. Okay. B. Now we have discovered from earlier that each increment here is worth 0.02. So if we have 9.7 and we need to add on 200ths to 9.7, B would be 9.72. Now, let's do C first. Where are you? C. Okay, so if A was 9.8, let's just go up in twos. So 2, 4, 6. Okay, so 9.8 plus 0.06. 9.86. Right, let's look at D now. So D, if you want to go backwards from A and take off 0.02, if you had 9.8 here, you would have 9.78 one step before. Now, on to E. E seems to be in the middle. It's not directly above the line. So if B was 9.72 and the next one along would be 9.74, the next one along would be 9.76. So in between that would be 9.75. If you're wanting to make this scale even more detailed, each of these small increments are worth 0.01. So A would be 9.75. F also seems to be in the middle. So if A was 9.8, we have 1, 2, 3 spaces along. So 9.83. And then we already spoke about G. So we've got G from earlier, 9.94. Okay, so let's move on to a different type of scale then. So this is in terms of litres, so your liquid volume here. Now, it's really important that you count the gaps. So if this is 1 litre and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gaps, okay? Half of 10 is 5. So after 5, you can see the larger line here. I'm going to call that 0.5 litres. That's half of 1 litre. Each individual increment here, so from 0, and each increment would give you 1/10. 1/10, 2/10, 3/10, 4/10, 5/10, all the way up to 1 whole. And then we're going to figure out how many more we need to add on. 1, 2, 3. So it was 1 full litre and 3/10. So the answer is 1.3 here. But please be careful when you are looking at the gaps in between the values. Okay, last example. Now we have here 9.8, 9.9, 10. So you can see that from 9.8 to 10, we are getting larger and we're going up in the scale. Okay, so the arrow seems to be in between two of the scales. So let's just have a further look at this. We have a gap of 1, 2, 3, 4, 5 here. Okay, and the full gap between 9.8 and 9.9 again is 0.1, because if you add on 1/10 to 8/10, you'll get 9/10. And again, just like the last example, if you have 10 and you divide that by 5, then each of these smaller increments would be worth 0.02, because 10 divided by 5 is 0.02. And if we wanted to go even more detailed here, then each of the smaller increments in between these black lines would be worth 0.01. So that's going to help us get the value of this arrow here. So we are getting larger as we go down. So we have here 10.0123. 10.03. And remember that each of these black lines were worth 2 hundredths, not 2/10. So the 0 still needs to stay here, because it was just 1/100th for my red lines, or if you wanted to do the 200ths first plus a 100th, it was 300ths that you got to for your final answer. So be really careful with these questions, and if you need any help, just ask. So can you please try your booklets pages 9, 10, 11, 12 and 13? Now, I've given you quite a lot of pages to do there, but that's mainly because most of the questions are just a case of inserting an inequality sign or just reading from the scale and writing the answer. So I do not think it will take you too long to complete these pages. But if you do need any help, please just ask me. Okay, enjoy.